Hello and welcome to this trainer for the Level 4 Diploma in Software Development Methodologies run by the British Computing Society, BCS. Over the next hour we're going to look at what this qualification is, why you need it, and thoroughly cover the topics that come up in the exam. A little about me. I'm Sam Morgan, Head of Product at Makers. I've been with Makers for the last 5 years, mostly as Head of Education across Academy and Apprenticeships. I'm really excited to be working with you today on this qualification. I'm extra excited to see if we can get you fully trained up in about an hour. So, thinking caps on, and keep the pause button ready. Let's do this. You can contact me at any time using my Slack handle or via email. So what is the BCS Knowledge Module? It's 3 things. A certification awarded by the British Computing Society. It's a requirement of the Level 4 Software Developer Apprenticeship. It's a model for how software development gets done in large enterprises. You might be surprised to hear that we can cover the entire qualification in just 1 hour, but many of the topics covered by this particular qualification are drawn directly from the workplace. Therefore, if you've spent more than 6 months engineering in a medium or large business, then most of the ideas will already be quite familiar to you. To get the qualification, you sit an exam. There are 3 components to the exam. And these are the main components of the exam. Questions are multiple choice, and the exam takes about an hour to sit. You sit the exam under controlled conditions at Makers. Let's break down each section of the exam now. The first 50% of the marks go towards understanding the software development lifecycle. That's understanding the role and function of the software development lifecycle, relating the 7 stages of the software development lifecycle, illustrating the main activities of the software development lifecycle, and demonstrating the deliverables of the software development lifecycle. So that's what you need to learn formally. But what does that mean in practice? In practice, things are a little simpler. You need to know what the software development lifecycle is and why it exists. You need to know the 7 stages that make it up. You need to know what happens at each stage and what is produced by each stage. This might seem like a lot, but as we'll see, the stages of the software development lifecycle are quite clear and fairly intuitive. If you've built software before, you've already used the software development lifecycle. The next 20% of the exam marks are reserved for software development methodologies. This is mostly about understanding 2 different ways the software development lifecycle can be used, Agile and Waterfall. Here's another way of stating those same topics we just saw. What's Agile? What's Waterfall? And why and when is one better than the other? You might get a feeling from all this Agile and Waterfall stuff that the examiner is stuck a little in the 90s. After all, most software engineering nowadays happens in an Agile way. But it doesn't hurt to understand how Agile emerged from Waterfall, or, if you're feeling more cynical, how Agile came to defeat Waterfall. The final 30% of the exam is reserved for questions about data, roles, and responsibilities. Like the rest of the exam, these questions are multiple choice. Relate the roles of a software project team. Illustrate the structure of a software development team in an organization. And explain what teamwork is required to deliver software projects effectively. And these assessment criteria aren't very clear, so here's another way of expressing them. Data, roles, and responsibilities are all about how a software team is constructed, how it fits within a wider organization, and how it delivers software. This is probably the trickiest part of the exam, as BCS expect you to remember roles and responsibilities that may no longer exist in your organization. So those are the 3 things you'll cover as part of this knowledge module. How to model software development using the software development lifecycle. How to pick the right version of the software development lifecycle, either Agile or Waterfall. And how to turn the model into a real working team, by deploying the right people. Here's what we'll do in this video. First of all, we're going to try and cover the whole syllabus in about 10 minutes. It's very fast, but it covers everything that you need to know. Then we'll get very practical. 2 stories of a startup and an enterprise using the software development lifecycle. There are some exercises after that. Then we'll focus on deliverables. What is expected to come from each part of the software development lifecycle? And at this point, we'll go deep. What are each of the stages in detail and who looks after them? What sorts of things get produced? And we'll make a lot of references to the official BCS text on this topic. Finally, we'll start to wind up with some roles and responsibilities, covering the 3rd module, Data Roles and Responsibilities, in more detail. And at the very last, we'll go through all the acceptance criteria one by one, giving clear examples, especially for the multiple choice questions on the exam. There are 3 paths that you can take through this video. The standard path takes in everything. And if you're pressed for time, you can take a shorter path and leave after deliverables. SDLC in detail and roles and responsibilities might help you pass with flying marks, but they're not really necessary for the exam. If you're really pushed for time, take the cramming path. That is, just stick around for this next section, bail at around the 15-minute timestamp, and jump straight to the end. Okay, let's get started. Although this video is called BCS Software Development Methodologies in an hour, let's start with a whirlwind tour of the entire syllabus in 10 minutes. And if you're really trying to cram right before the exam, watch this bit, then skip to the end. Let's start with a quick warm-up. Think back to the last time you were working on a software project. Who were you working with? What were their job titles? What did they spend most of their time doing? What sorts of things were they focused on delivering, and what was your role when interacting with them? Pause the video now and take a couple of minutes to jot down some thoughts. The video will resume in about 10 seconds. There were probably a few different roles, responsibilities, and deliverables in the example you just thought of. You might have come up with product owners and project managers working together to create a project plan, domain experts working with users and business analysts to come up with the requirements for a project, maybe technical architects developing designs, software developers writing code and creating working software, testers creating test plans and specifications, maybe release managers managing deployment plans, database and system administrators working together to roll out a project. The software development lifecycle is what all of these people are going through when they work together to launch a new product. Whether they're working in an agile way, a waterfall way, or something else, the steps they take and the deliverables from those steps are always the same. The software development lifecycle is broken down into 7 stages, each with people to take responsibility for producing a deliverable from that stage. Except these people. Technically, these people are managing the whole thing. Each stage of the software development lifecycle has a name. The first stage, where product owners try to convince the business that a project is worthwhile and create a project plan, is called the feasibility study stage. Business analysts usually get involved with this stage too to find out if the idea will produce a good return on investment or ROI. The second stage, where business analysts work with domain experts and users to nail down the exact requirements for the product, is called the requirements analysis stage. The third stage, where technical architects try to produce a system design to meet the given requirements, is called the design stage. Business analysts tend to be involved in that stage too. The fourth stage comes when the system, or at least a part of the system, has been designed. Software developers build to the design specification in the code development stage. At the fifth, or testing stage, software testers produce a thorough test plan, and test scripts to make sure everything that's been built meets both the design and the requirements. Software developers often get involved with the testing stage too, as do business analysts, since they can bring users with them to try the product out. If all went well, then we're at stage 6 and we can deploy our application. This is the deployment or implementation phase, and a release manager will produce a deployment plan to get the product live. Again, software developers are usually pretty heavily involved with this stage of the lifecycle. Last of all, there's the maintenance stage, which covers every kind of supervision a live product needs, from bug fixes and enhancements to administrating it effectively. So those are the 7 stages of the software development lifecycle. At a high level, they exist to take a set of business requirements and translate them into an operational IT system. Each stage has a group of people responsible for producing certain deliverables, and each deliverable helps the people in the next stage to produce their deliverable. But what about Agile and Waterfall? Well, this is all about the order you do the stages of the software development lifecycle and how often you repeat them. That's the difference between Agile and Waterfall. Say you do all the stages in order. Only start the requirements analysis after the feasibility study is done and signed off. Only start design once you've signed off all the requirements, and so on. That's Waterfall. Do the stages of the software development lifecycle in order. Sort of like water flowing down a waterfall. Do you want to go back to a previous stage? You really shouldn't. Do not go up the waterfall unless you're willing to lose work from the stage you're currently on. To avoid finding out that you need to redo a stage later, only move on from one stage to another once you've got sign-off on the appropriate deliverables. So that's Waterfall, and what's wrong with it? Why would we need anything else? Let's have a look at these first 3 steps in the SDLC. What if these business requirements change during the course of a life cycle? Isn't it quite risky to do this much design up front, especially since we can't go back a stage later? Well, one way we could solve this would be to move in smaller, shorter software development life cycles, like mini waterfalls one after the other, or cascading waterfalls. And this is the idea of Agile. Agile still uses the software development lifecycle, but it's quicker with it. Agile does short, iterative, repeated loops of the entire cycle, with lightweight versions of the deliverables. Agile also encourages the people who specialize in each stage to work across multiple stages of the lifecycle, and moves backwards and forwards up and down the cycle stages whenever new information becomes available. So what's better, Agile or Waterfall? The answer is, it depends. If your problem is very complex and the requirements are likely to change, then Agile is your best bet. But if you're working on something that's been done 1,000 times before and the requirements are stable, Waterfall can be easier to manage. Keep the project driving forward. It can be easy to control cost and scope, and it's altogether quite an intuitive and simple model. So here are 3 examples. Example 1. You're trying to prove a concept without wanting to invest loads of effort, money, and time. Which do you pick? Agile or Waterfall? Pause the video now if you want to decide. Agile's prototype-first approach delivers value rapidly, whereas Waterfall will take a long time to deliver anything working. Likewise, if your project proposal is very risky, Agile will allow you to prioritize building the most high-risk parts of your system first, potentially discovering problems before too much cost has been incurred. And whereas Agile delivers working value continuously, Waterfall projects that fail due to unforeseen risks won't deliver anything at all. Second example. Let's say you were building a product in a heavily regulated space, like healthcare or aerospace. What do you pick? Pause the video now if you want to choose. In this case, you might want to take the less experimental Waterfall approach, so you can specify all your requirements in detail up front, and formally review each deliverable before any work in the next stage can get started. Final example. Let's say you take a contract with a company that's recently been hurt by a very expensive failed software project. They want to be absolutely sure that their next one will succeed. Which approach would you recommend? Pause the video now if you want more time to think. Well, a waterfall approach might appeal. After all, waterfall demands thorough and clear agreement on requirements and scope up front. However, taking a waterfall approach puts a lot of pressure on the company's BAs to scope and estimate correctly at the beginning, with big costs for discovering new requirements later on, say in the testing stage. So at the same time, since so much of the waterfall SDLC happens without any user engagement or input, basically all the stages between getting the requirements and being able to test the product, waterfall runs the risk of freezing the customer out by presenting software development as a bit of a black box. Not talking to your colleagues for months is not a good look for a software department where people are probably wary after last time. So it's got to be agile for me, if only for the collaboration that it forces with the customer. And that's it. We really have just covered the whole course in under 10 minutes. One thing I'm hoping to prove to you during this video is that the software development lifecycle isn't large, scary, or complex. And to do that, I'm going to start with two stories which both follow the lifecycle. One is about how a few friends use the SDLC to start their startup. The second is about a larger enterprise. Cat Sitter was started by housemates Janine and Paula in 2018, when they had to look after a friend's cat at short notice. Janine and Paula figured there must be some way to make money from connecting cat lovers in their local area, and Paula knew how to program, so they set to it. Business-minded Janine put together a high-level project plan containing some market research on local cat enthusiasts. The plan detailed the business model, which was to charge users a fee for connecting them with local cat lovers. Once they'd hit 300 users a month, they'd make their investment back. Next up, Paula set about translating Janine's business requirements into clearer requirements. They decided that the app should log in through Facebook and send users monthly emails to notify them of new cat lovers in their area. Paula contacted a designer friend, Martin, who was able to help turn these requirements into wireframes and sketches of the interface. At the same time, Paula decided to build this app in Rails and sketched out the trickier components that she would need to build, one for signing up and one that needed to be really secure for making payments. Then, Paula implemented her and Martin's design in code. Every week or so, Paula would sit down with Janine and Martin to run the code she'd built and get feedback that it was working in the way she expected. Janine brought in other friends to try out Cat Sitter and offer feedback. They caught a few bugs this way, and they amended the requirements a couple of times to better serve their users. Finally, launch day came. After a final run-through, Paula pushed her app up to Heroku and sent it live, and Cat Sitter was released to the world. Janine, Paula, and Martin were overwhelmed by their success, and within a couple of months, Paula had brought on 2 extra team members to handle scaling the app and building new features like chat into the platform. So that's the story of Cat Sitter. And although it was just a handful of friends trying out an idea, the Cat Sitter project development still used the software development lifecycle. Try pausing the video at the next screen and matching the events together with the stages. So pause the video now and try to connect the stages of the Cat Sitter project to the software development lifecycle. Here's what I came up with. Market research on local cat enthusiasts demonstrated return on investment in the feasibility study. The decision that the app should log in through Facebook was a requirement as part of the requirements analysis. The component that Paula sketched out for the payment system was a deliverable of the design phase. A working Rails app was the deliverable of the code development phase, working code. Gathering feedback from friends formed the main part of testing. And releasing Cat Sitter through Heroku was the deployment/implementation. And the post-deploy bug fixes, as well as the features that got added, were all activities during the maintenance phase. Okay, so that's Cat Sitter using the software development lifecycle. Now, let's try it in a large company. Acme Inc. had been providing systems which help with regulatory compliance for healthcare for nearly 80 years. In 2012, they launched their first software suite for hospitals, which was an early success. In the years in between, they've been able to sit back and watch the rivers of money roll in, providing consultants on a lucrative day rate to clients for support. In 2016, Acme brought on a new CTO, Miriam. Miriam was brought on because of her recent success rewriting the stack for a large media company, saving them millions in server costs and dramatically increasing reliability. Acme's uptime was only about 96%, so they had a large third-line support team ready to handle customer queries for those critical situations when the system was down. Miriam and her team calculated that they could redistribute up to 80% of the members of the third-line support team and reduce their reputational risk if they rebuilt Acme's software on a newer distributed stack. Various business analysts got involved in producing the business case, which demonstrated a clear return on investment within 6 years of completion. The case went to the board, was duly signed off, and work could begin. Miriam started by building an effective team of analysts, scrum masters, and technical architects to work with. Together, they roamed around the business, gathering requirements in quite a lot of detail. They religiously prioritized the requirements they found, streamlining them into a backlog containing only the highest value items that they heard from a lot of places around the business. Given the software was being built for the healthcare industry, they also engaged medical experts and patients, running a set of initial consultants. All part of the requirements analysis. Next up, the technical architects began to design the riskiest parts of the system. Acme was already renowned for regulatory compliance, so a great deal of collaboration with business analysts on detail work was required. At the same time, Miriam instructed the technical architects to begin selecting and training their lead developers. The architects produced a variety of functional and non-functional designs, intricate components which guaranteed security for patient data, mapped out in UML or Universal Markup Language, and high-level interface ideas for nurses doing their rounds on the wards. So code development began almost the moment the first designs dropped down from the architects. Miriam organized development teams into streams, who would quickly get code out of the door for user testing and validation or refinement of the designs. Streams were responsible for a small number of microservices, from writing them all the way to deploying them, which helped keep streams from getting mixed up with one another. As a result, code began shipping to alpha users of the product within 6 months of Miriam joining. The business continued to work up and down the various stages of the lifecycle in their streams, releasing frequently to alpha and then beta users in order to get real-world feedback on the system. And rather than a single big launch, Acme gradually rolled out the new product. As it did so, the company provided guidance and documentation for its client-facing consultants and reassigned a large part of the third-line uptime service to customer support roles. Of course, Miriam and her team continued to iterate on the product, gradually increasing the feature set and building tools to help move from the old system across to the new one. So that's the story of Acme. Although Miriam drove a very agile approach to this project, you'll see that all the stages of the software development lifecycle were used, and mostly in order. Try pausing the video at the next screen and again, matching the events together with the stages. Pause the video now and try to connect the stages of the Acme project to the software development lifecycle. Here's what I got. When the board signed off to rebuild the stack, that completed the feasibility study. When business analysts were prioritizing the backlog of requirements, that was all part of requirements analysis. UML diagrams from the tech leads and the technical architects for the most regulatory critical parts of the system formed part of the design. A distributed system of microservices was the deliverable of the code department. Alpha releases gave important data for testing. A stream deploying their service to an Amazon Web Service was an instance of deployment or implementation, although I did mention that streams could pick their own deployment routes. Documentation and training for consultants to help with transitioning customers was part of maintenance. So that's both CatSitter, a small company, and Acme Inc., a large company. and both of them use the software development lifecycle. In fact, it's sort of impossible not to use it. So let's take a moment to go back to the assessment criteria. Here are the assessment criteria for the first 50% of the exam, and we've covered these three in quite a lot of detail so far. You should by now know the stages of the software development lifecycle and what happens during each stage. But before we move on, let's dive deeper into the deliverables of each stage and what those are for. So what is a deliverable? A deliverable is what gets passed from one stage of the SDLC to the next. What's a deliverable for? Well, the purpose of a deliverable is to enable the next stage of the SDLC to happen. Let's imagine that something goes wrong in the design stage. A technical architect leaves and doesn't arrange enough cover for the work that they're in the middle of. In that case, their design phase won't produce the correct deliverables for the code development phase which follows it. So they're going to be missing some designs that they were meant to get. And this could hinder the code development phase. They may not know then how to build that part of the system, or they may then need to rework it. So deliverables are critical. They keep the flow of information moving between individuals and teams throughout the SDLC. They're like important links between the stages of the lifecycle. If the stages of the software development lifecycle were all questions, you could think of deliverables as answering those questions. Let's imagine that conversation now. The feasibility study asks, oh, what's the return on investment? And the deliverable answers it. It's a feasible business case, demonstrating there's a return on investment. The requirement stage says, well, what exactly should the system do to meet that return on investment? And the deliverable says exactly this, a prioritized, validated requirements document. So the design then says, well, how should the system achieve those requirements? And what is produced is a solution to the requirements document, a design specification, sometimes called a design solution. Then code development stage asks, what code could we write in order to meet the design specification? And the answer to that is working software components. That's the deliverable from that phase, which implement the design solution. So then testing asks, is everything definitely working and how do we know? And the deliverable answers that with a completed, documented test plan, validating that the system meets all of the requirements. Then the deployment and implementation phase says, how do we go live? And after producing a plan for that, the deliverable is simply an operational live system in the live environment. Then the maintenance phase asks, how should we support the thing now that it's live? And the deliverable is a maintenance plan for administrators. So now that we've got a list of the stages and their key deliverables, let's dive into them a little more. This isn't necessary for the exam, but it might be interesting to learn a little about what and how these deliverables come to be in practice. So let's start with the feasibility study. The key question is, what's the return on investment from this project? And the key deliverable which answers that is a business case, which demonstrates ROI. Business analysts, executives, product owners, and project managers may be involved at this stage. Next up, the requirements analysis. The key question here is, what exactly should the system do? And the key deliverable which answers that is a prioritized, validated requirements document. Business analysts work across the business, bringing in domain experts such as the healthcare professionals we saw in Acne Inc. earlier on, and users such as the medical patients that we saw in that same example. There are many different ways to formally represent requirements. Generally speaking, we want to capture both functional requirements, which list out the things a system must do, and non-functional requirements, which list out how a system should be. Examples of non-functional requirements include being user-friendly, reliable, secure, accessible to those with special needs or specific internet connections, available with little downtime, with enough capacity for sustained high-volume usage and enough throughput to manage sudden volumes, and several more. See page 140 of BCS's Developing Information Systems for more. Much of the content in this video is drawn from that book, so it is a good resource. Oh, and last thing, user stories are an example of a requirements analysis deliverable. After the requirements document is produced, or if we're agile, some of the requirements have been clarified and prioritized, we move on to the design phase. The key question here is, how should the system achieve the requirements? And the key deliverable which answers that is a design solution, or sometimes called a design specification. In a traditional organization, technical architects own the design phase, producing detailed documentation for exactly what is to be built. Nowadays, because designs are often far too complex for a single technical architect to handle, the work may be broken down into teams or onto other roles, such as business analysts or developers, who may get involved with the design. Like requirements, there are many different ways to formally represent designs. Generally speaking, there are 4 high-level areas. Input-output designs, which describe the program interfaces. Data designs, which describe the data storage structure. For instance, the structure of tables and rows if we're using a relational database. Security and control designs, which describe the physical safety of the system as well as how access will be controlled and managed, basically how to avoid being hacked. And process designs, which describe the flows of information inside a system. This last group of designs is rather large and could involve any number of diagramming techniques, but especially popular are Universal Markup Language, or UML, Entity Relationship Diagrams, or ERDs, State Transition Diagrams, and Sequence Diagrams. And while you won't need to recall any of these detailed specifics for the exam, I do recommend pausing the video and Googling for examples for each of these diagram types. Regardless of how strict your company is about their design phases, each type of diagram is a useful tool for communicating your ideas with colleagues. Ultimately, ability at doing so is a requirement for the job of technical architect. So after the design phase, we enter the most familiar stage to us, code development. The key question here is, what code do we write in order to meet the design specification? Our key deliverable is, quite simply, working software. Now, you might find it a little bit fishy that design, development, and testing are 3 separate steps, especially given how test-driven development encourages you to both write tests and design your code in order to write implementation. And you'd be partly right to find this strange. But there are 2 answers. One is that the SDLC is a model of how software gets made, and therefore, as a model, it doesn't perfectly fit with reality. Another answer is there are many parts of design and testing in the SDLC stages which sit outside of core TDD. For instance, designing a cache to be hit hundreds of thousands of times a minute reliably, or beta testing a system to gauge its usability with a group of users isn't exactly TDD, but they are design and test phases of the SDLC. So, the SDLC is both not a perfect fit for modern practices, but it fits well enough. After we have some part of the system working, it's time to road test it. We need to validate 2 main things. 1, that the functional requirements of the system are met, that the system does what it's meant to do. 2, that the non-functional requirements of the system are also met, that the system feels like it ought to. Software testers produce a completed test plan, containing a requirement specification, which proves the system meets the requirements in the requirements document, a functional specification, which proves the system does the job for users it's meant to do, and this is measured by acceptance tests, hence the idea that the user is accepting the specification. Then there's a design specification, which proves the system meets the design solution that was laid out in the design phase. And lastly, a program specification, which is made up of unit and integration tests, which check that each subcomponent of the system behave as expected, both in isolation with unit tests and within the context of other components with integration tests. It's not unusual for new, unexpected requirements to be discovered during the testing phase. This is expected for an agile project, but unexpected requirements can cause major pain for waterfall projects, since this data arrives late in the development lifecycle. If our system meets the various specifications and requirements, it's time to go live. Here, a release manager will oversee the launch of a system. In more modern workplaces, such as those which practice continuous deployment, release managers may be one and the same as software developers or software testers. Teams may share responsibility for managing the smooth deployment of their features, and this may result in release managers being unnecessary or adjusted. Once the system is live, it must be maintained. Ideally, there is a specialist team of administrators for this purpose. Regardless of how effective that team is, bugs and enhancement requests are a fact of life for a software team. The work of maintaining a well-built product is usually around 20% bug fixes and 80% new features. So that covers the full set of deliverables in some detail. Let's go check our acceptance criteria again. What's the return on investment? A business case demonstrating the return on investment. What exactly should the system do? Use a requirements document with functional and non-functional requirements, perhaps even user stories, to detail this. How should the system do it? A solution to the requires document might use UML, sequence, or process diagrams, as well as interface diagrams, data structures, and security considerations. What code do we write to meet the design specification? Working software components should implement that design solution. Is everything working, and how do we know? Well, a suite of tests across the functional and non-functional requirements, including acceptance tests, system tests, integration, and unit tests, should tell us this through a completed, documented test plan. How do we go live? Well, we put the system live in the operational environment, many teams taking responsibility for that, and it may not be a release manager who does it. Lastly, maintenance. How should we support this thing? And a maintenance plan for administrators, including system and database administrators, should also be created. So here are the assessment criteria for the first 50% of the exam, and we've now covered all of them. Since we've covered Agile and Waterfall in some depth already early on, let's spend the remainder of this video discussing the roles and responsibilities in software teams, which is the remaining 30% of the exam. Remember from earlier that these are the data roles and responsibilities assessment criteria, and we simplified them like this. Can we use our new in-depth knowledge of the software development lifecycle to answer these questions? I bet we can. Let's quickly run through all the roles in the team so far. Next to each one, let's remind ourselves of the parts of the SDLC the roles most concerns itself with. For the business roles, we have a project sponsor who's running the project, a business analyst who does feasibility and requirements work, a domain expert who may be brought in to do requirements work, such as nurses or doctors in the healthcare example, or pilots if you're working in aerospace, end users who join for the requirements and testing. Then there are project roles, like the project manager and team leader. There's technical roles, like the technical architect who mostly produces designs, a solution developer whose job is, of course, to produce code, a solution tester who ensures that everything is working and meets the specification. Then there are the implementation or support roles, a release manager who works during the deploy phase, alongside a database administrator and a system administrator who also continue to maintain the project in production. Now, how do all these roles fit into a wider business? And what is a software development team within that? For software development team, let's just use the technical roles from the previous slide. That is, the technical architects, developers, and testers who make up the software development team. So where do these people fit in the software development lifecycle? The specific answer to this depends on how the team likes to work. Traditionally, software development teams didn't interact much with requirements directly or the end user, so they mostly lived here. A little design, a lot of development, some testing, and a little deployment. Nowadays, it's normal for software developers to engage with much more of the lifecycle, something like this. Software development teams get involved with gathering requirements, building the design specification, sitting with users during testing, and maybe spending days off-site with system administrators, helping out during the maintenance phase. Of course, there's still a sort of surrounding cloud of business, project, and implementation roles all around the software development team, with specialisms at different points of the lifecycle. Software development teams don't sit in isolation. Let's spend the last part of this video looking at the ways in which poor teamwork can make a project go wrong, and how good teamwork can help it go right. Let's play a game. Let's start by representing the roles in an organization. For the business roles, we have the sponsor, business analysts, and users. And on the project side, we have a project manager. Technical roles-wise, we have the technical architect, developers, and testers. On the implementation side, we have the release manager, the system administrator, and the database administrator. We're going to play a game. You now know a great deal about the software development lifecycle, the deliverables due at each stage, and what parts everyone is meant to play. Using just these roles on the screen, how many ways can you spot for a project to go wrong? I'll get you started. If the BA and the sponsor don't align as per the dotted white line, it's unlikely the feasibility study will ever get signed off and the project is dead. Here's one more before you try. If the technical architect operates in isolation from the business analysts, then they risk designing a system which doesn't suit the requirements, just a sort of personal project. In that case, it's a custom system, everyone's wasted their time, and the project is dead. Okay, now it's your turn. Using just these roles on the screen, how many ways can you spot for a project to go wrong? Come up with some further disaster scenarios and, if you like, drop them in the comments under this video. And that takes us to the end of this video. So today we've covered the full BCS Level 4 Diploma in Software Development Methodologies syllabus. That includes the software development lifecycle, software development methodologies, and data roles and responsibilities. Your next step is to go take some practice papers. If you found the topics interesting and you want to read more, I recommend a copy of Developing Information Systems, Practical Guidance for IT Professionals by James Cadle, published by BCS. And finally, go sit the exam. There's no better way to test your knowledge than trying it out for real. And if you'd like to get in touch with me to ask questions, I'm at Sam on Slack and sam@makers.tech via email. Thank you for joining me, and good luck. Oh, did you think I'd forgotten the cramming section? The next 5 minutes of this video should be just about enough to pass the multiple choice exam, although I sure hope you didn't just come here for this. We're going to go through each of these assessment points and answer them in under a couple of sentences each. Explain the role and function of the software development lifecycle. It's to take a set of business requirements and, through a series of structured stages, translate them into an operational IT system. Relate the 7 stages of the software development lifecycle: feasibility analysis, requirement analysis, design, code development, testing, deployment/implementation, and maintenance. Illustrate the main activities of the software development lifecycle. Product owners and BAs make a business case based on return on investment. Then they work with the users to define requirements. Technical architects use the requirements to design the system, and software developers implement the system, it's deployed, and administrators maintain it. 4. Demonstrate the deliverables of the software development lifecycle. A project plan becomes requirements, becomes a system design, is translated into working software, tested against a test specification and plan, released according to a deployment plan, and becomes an operational IT system. 2. Software development methodologies. 1. Describe the main differences between Agile and Waterfall. Waterfall is linear, Agile is evolutionary. Waterfall does the software development lifecycle stages in a defined order, with each step 100% completed before moving on. Agile assumes that the requirements will change, so it iterates on the SDLC, repeating stages where necessary. Explain the respective strengths and weaknesses of Agile and Waterfall. Waterfall is simple, intuitive, easy to manage, easy to control, and effective in highly regulated spaces. However, it's expensive to rework completed stages if new requirements are discovered. Poor estimation can wreck a project, and it can turn projects into a black box within an organization. Agile, on the other hand, is experimental, collaborative, provides early value or risk assessment via prototyping, and handles complex or changing requirements. But it can be difficult to manage, and it may result in scope creep. Demonstrate the selection criteria for choosing Agile or Waterfall. Is the process complex? If yes, probably Agile. Are the requirements stable? If yes, Waterfall's in with a look. Does the customer need value quickly? If yes, Agile because of the prototyping. Are there high regulatory requirements? If yes, waterfall, because we should spec it up front. Is the team management effective? If yes, agile, because agile is harder to manage than waterfall, so you should have effective management if you're going to pick it. Finally, data, roles and responsibilities. Relate the roles of a software project team. From the business, there's a product owner, business analysts, domain experts and users. To manage the project, there's a project manager. To do the technical work, there's a technical architect, software developers and testers. And to implement and maintain, there are release managers and system and database administrators. Illustrate the structure of a software development team in an organization. A development team sits between the BAs and the maintainers. Technical architects handle design, software developers code development, testers the testing, and release managers handle the deployment/implementation, although of course in real life the roles are blurrier than this. Explain what teamwork is required to deliver software projects effectively. Everybody above must deliver software development lifecycle deliverables for their respective stage, supporting roles in other stages where appropriate. And that concludes our cramming session. Good luck with your exam.